So let's look at another example, shall we? In this example, a hydro pole is to be secured to the ground 10 meters away with a guy wire as shown. And I've drawn this picture in, and this would be the picture given to you. Now, a definition here that's useful to know is that a guy wire is simply a wire that is attached to the top of a pole and then to the ground. Using a device known as a clinometer, a person measures the angle of elevation to the top of the pole to be 30 degrees. So an angle of elevation, again, is the angle that is measured from the horizontal in an upward direction. So we have a 30-degree angle there. How high is the hydro pole? So with this problem, the first thing I'm going to do is put a variable in for what I want to solve for. And in this case, I need to solve for the height of the pole, so I'm going to put an h there. So I see I'm given an angle and a single side, so my primary trig ratios pop into my head. And what I'm going to start by doing is writing out Sohcahtoa. And again, as I get better at this, I can do this without this step. But for those of you that are learning this for the first time, this is a useful technique. So I'm given the angle, so I check mark S, C, and T because it's sine of an angle, cos of an angle, or tan of an angle. I want to solve for the h, which relative to the 30 would be the opposite side. So I need a ratio that has the opposite in it. So that leaves me either sine or tan. And then I'm given the adjacent. So I see that the only case where I have all three checks is tan. So that means I'm going to use tangent to solve this. So I know tan of 30 degrees, and again remember that degree symbol, is equal to the opposite, which is h, over the adjacent, which is 10. So when I rearrange this, I multiply both sides by 10, so I get 10 tan 30 degrees is equal to h. So h is approximately equal to, and don't forget this approximate symbol now, 5.774 meters. 3 decimals is good there. Therefore, the height of the pole is 5.774 meters. And we're done. Now this next question, it says, what length of wire will be needed? And I'm going to do this two ways. So let's use method 1 is I'm simply going to use Pythagorean theorem. So now I want to solve for this length, so let's call that L. Put a label in my diagram so I know. So L squared is equal to 10 squared plus 5.774 squared. So L is approximately equal to 11.547 meters. And I feel pretty good about that because of the fact that it is the largest side and it is opposite of the 90-degree angle, meaning it's the hypotenuse. But if I wanted to check this, I could actually use a second method. And that is relying on my trig ratios. So I'm going to write out Sohcahtoa here. So in this case, I want to solve for the hypotenuse. So I need a ratio that has the hypotenuse in it. I'm given the angle 30 degrees, so I could use sine, cos, or tan of that angle. And then when I look, and now, so we have the angle we said, we have the hypotenuse, and since in the last question I calculated that the height, I could use that, but since I was given the 10 meters, I'm going to go with using the adjacent. So that means I'm going to use cosine. So cos of 30 degrees is equal to the adjacent, which is 10, over the hypotenuse, which is L. So L cos 30 degrees is equal to 10. So L is equal to 10 divided by cos of 30 degrees. Let's come up here. I'm just going to type that in my calculator now. And I see that I get L is approximately equal to 11.547, which is the same answer. So therefore, the length of the guy wire is 11.547 meters. I hope that helped.